welcome everyone. Myself G. Vijay Kumar, Assistant Professor from Department of Biomedical Engineering. Today I am going to present one topic from digital electronics. The topic is half adder and full adder. First we are going to see what is adder. So an adder is a digital circuit used to perform binary addition. It takes binary inputs and produces two outputs that are sum and carry. Adders are fundamental building blocks in arithmetic and logic operations inside the digital systems. Adders are combinational logic circuit. It is also called as combinational logic circuits. Half adder adds 2 bits and full adder adds 3 bits. Before entering to the concept, we need to know the logic gate operation. So logic gates are the fundamental building blocks of all digital circuits. They perform basic logical operation, one or more binary input to produce a single binary output. Binary input and output exist in two levels: logic 0, logic 1. Low means 0 volt, high means 5 volt or 3.3 volt. So now we are going to see AND gate. An AND gate performs a logical multiplication operation. The output of an AND gate is high only when all of its inputs are high. That means 1. If any one of input is low, the output becomes low. This gate represents the Boolean expression Z equal to A dot B, because this is the multiplication operation. Next we are going to see OR gate. An OR gate performs a logical addition. The output of an OR gate is high. That means 1. When any one or more inputs are high, the input becomes low only when all inputs are low. The Boolean expression for the OR gate is Y equal to A plus B. NOT gate. So a NOT gate has one input and one output. It produces the complement of the output. If the input is high, output is low. If input is low, output is high. It produces the inverted output. That means Y equal to A bar. Next we are going to see buffer. Buffer is nothing but if input is 0, output also 0. If input is 1, output also 1. So next we are going to see NAND gate. The NAND gate is inverted form of the AND gate. That means just opposite of the AND gate is called as the NAND gate. Its output is high for all input combination except when both inputs are high. That means when 1 comes, that times output is 0. So NAND gate is known as a universal gate because any logic circuit can be performed using only NAND gate. Boolean expression for this gate is Y equal to A dot B bar. Next we are going to see NOR gate. The NOR gate is the inverted form of the OR gate. That means just opposite of the OR gate is called as the NOR gate. So the input is high only when all inputs are low. It is also a universal gate. So Boolean expression for this gate is equal to Y equal to A plus B whole bar. The XOR gate gives high output when the inputs are different from each other. If both inputs are the same, that means 0 0 or 1 1, the output is low. XOR is widely used in adders, parity checkers and digital comparators. The Boolean expression for this gate is Y equal to A plus B. Next we are going to see exclusive NOR gate. The XNOR gate is the complement of the XOR gate. It is just opposite of the XOR gate. Its output is high when both inputs are equal, used in digital equality detectors. So these are some basic operations of the different logic gates. Based on this gates operation, we are going to develop our adder circuit. So there are two types of adder circuits are available, that are half adder and full adder. So circuit also shown here. Now we are going to develop how we are going to draw this circuit by using the truth table and Boolean expression. So first we are going to start with half adder. So half adder is nothing but it is a combinational logic circuit used to add two single bit binary numbers. It produces two output that are sum and carry. It cannot add the carry from a previous stage, hence the name half adder. So this is the half adder block diagram. So here A and B is the two input and sum and carry is the output of the half adder. So here is the truth table for this half adder is available. Plus 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is also equal to 1. These three steps are comes under real mathematics. Now we are going to see 1 plus 1 is equal to 1 0. That in real mathematics 1 plus 1 is equal to 2. The equivalent binary value of this 2 is 1 0. Here this 0 goes to the sum, this 1 goes to the carry. This is the truth table for this half adder circuit. So here is the detailed half adder truth table available. When input A is equal to 0, B is also 0 means here sum also 0, there is no carry, so that we have to use default value 0. So here when A equal to 0 and B equal to 1, that time also our sum is equal to 1. So here also no carry, so that we are using default value 0. Next 1 plus 0 is also 1, so our carry is 0. Here when we are going to add two high values, that means 1 plus 1 is equal to 2 in real mathematics. The binary value of this 2 is 1 0. Here 0 will be the sum, that 1 will be the carry. Based on this output, we are going to develop Boolean expression to draw the circuit diagram. First we are going to take sum. Here now I am going to take when sum output is equal to 1, when it is actually A is equal to 0 and B is equal to 1, that time our sum input is equal to 0. Here we are going to develop Boolean expression. So A equal to 0, that means A equal to complement. So A bar dot B bar plus next A, because A equal to 1, B equal to 0. So this expression will come. So next we have to convert this expression into XOR gate. So this expression shows the XOR gate. So I am using XOR gate here, A XOR B. Next we are going to check when carry output is equal to 1. When actually A equal to 1, B equal to 1, that time only our carry input will come 1. So A dot B is the Boolean expression for the carry. So now we are going to implement our half adder circuit. For generation of sum output we are using one XOR gate. For some generation of carry output we are using one AND gate. So here is the XOR gate available. A and B are the inputs and the sum is the output. So sum output we have generated by using the XOR gate. Now we are going to generate carry output. For that we are using AND gate. So AND gate we are using same inputs. Here two inputs are A and B, and carry we have to generate by using the AND gate. So here carry. By using XOR gate and AND gate we have the half adder circuit. This is the concept of half adder. Now we are going to see what is full adder and how it is works. A full adder is a combinational circuit that adds the three inputs that are A, B and carry in. So this is the block diagram. So now this also generates two output that are sum and carry out. So full adder also working on the principle of it adds the three bits A plus B plus C in, that means carry in, following binary addition rules. So this is the full adder truth table. Here we are going to identify how many combinations available, because base of the binary is 2. Here our input is 3, so 2 power 3 is the 8. So 8 combinations available, so that we are using 8 combinations A, B, C. Here is the combinations available. Same we have followed the binary addition rule here also. Now we have to solve this truth table by using the binary addition. So here also two outputs, sum and carry. Now we are going to develop our full adder sum output generation boolean expression. So this also same, when our sum output is equal to 0, that one we have to take for boolean expression, so that our boolean expression is S equal to A XOR B XOR C in. So now we are going to see how we are going to develop our carry output boolean expression. So this also same, when our carry output is equal to 0, that one we have to take to develop our boolean expression. So our boolean expression is finally carry out is equal to AB plus BC in plus AC in. So these are the our implementation of the full adder circuit by using our boolean expression. There are two methods available to implement the full adder circuit. Method one is the two alpha adders plus OR gate. So first alpha adder adds A and B, produces S1 and C1. Second alpha adder adds S1 and C in, produces sum and C2. Carry out is equal to C1 or C2. This is the most common and realization method. This method is used for exam purpose for easy understanding. So method 2 using gates XOR and OR. So XOR gate generates sum and OR gate generates count Cout. And OR gates generates Cout. These are the two methods used to implement full adder circuits. The difference between alpha adder and full adder is nothing but it is only the difference. Alpha adder adds the 2 bits, full adder adds the 3 bits. So it is the working concept of alpha adder and full adder in the digital electronics. Thank you so much.